So at this point I want to introduce a notion to sort of keep in the back of our minds along this line of, are real numbers real? So if you imagine 2 points in space and you ask for the distance between them, it could end up being exactly 2 or 3, but probably not. It could be a nice fraction like 2 3/4 inches or something like that, but probably not. Most likely the distance between them is a decimal number. And unless you've placed these very deliberately to be something like 2.5 inches apart, we need a real number to describe that distance. The famous example from Greece is, make a square with a length of 1 on each side and ask for the length of this diagonal, and it's a real number. It's not a whole number, it's not a natural number, it's also not a fraction. It's 1.414 something, which is actually the square root of 2, which is not even a fraction. And this was discovered by the Greeks, 2,000 plus years ago, that you can't write this as, some whole number over another whole number. So it feels like, the universe is described best by real numbers. But in fact, if you talk to physicists, they will tell you that the universe is not as it seems. And in fact, if you try to place 2 objects in space, you can't really place them at arbitrary locations. The reason being that space is not continuous, but it's quantized. And when things move what looks like smoothly, they're actually jumping from one spot to another. And so there's a thing called the Planck distance, and it's about 1.6 times 10 to the negative 35th meters. And that's sort of considered the smallest length possible according to physics. And when you try to take things smaller than that, our classical understanding, our Newtonian understanding of physics breaks down. It doesn't work anymore. And so some physicists will tell you that space itself does not move smoothly between one point and another, but there's these discrete locations. And that time is also quantized. And if you had a very, very precise clock, you would find that time does not smoothly change from one instant to the next with arbitrary precision, that in fact it jumps, and that there are 2 moments in time that cannot be subdivided. And so real numbers may be more powerful than we need to consider the universe. We may need very, very precise, perhaps rational numbers, perhaps scaled integers, but we may not need the full precision of real numbers. Using the same argument of the number line, it may be that if you have a series of objects as close to each other as possible, that if you start with one object, it actually is possible to say what's the next object, because it's not a continuous set of locations that something can exist in, it's discretized. So that gets off into a whole different area, but it's something to keep in the back of our heads as we start taking apart what we can do with real numbers and seeing some of the ways in which they kind of break our intuition.